So in this lesson, we're going to talk about the angles inside and outside the circle. These are the ones that aren't in the center and they're not on the circle, but they're either inside the circle or outside. So here are three possible pictures. Here are two secant lines. Remember, a secant intersects the circle twice. And we have this angle outside the circle. And then if you notice, there are two arcs that these secants intersect. There's a big arc and a little arc. Over here in figure 2, we have a tangent line that touches the circle once. We have a secant line that touches the circle twice. And again, you'll notice we have a big arc and a little arc. And the last one, we could have two tangent lines that intersect the circle. And notice we have a little arc and a big arc. Important thing to notice about this last picture is my two arcs put together add up to 360. So when we're talking about finding these arcs, we're going to call one of them X, and we're going to call the other one 360 minus X, because these two arcs together add up to 360. And we'll talk about how we find that angle. So here's the rule for those. The measures of arcs formed by secants and tangents that intersect outside the circle are. So we're going to say the angle equals half of the big arc minus the little arc. So we're going to take this big arc minus the little arc, divide it by 2, and that's going to give us the angle. So that's our rule for that one. So I'll give you an example here on this page. This question says find X. So you notice we have our two secant lines, and there's a big arc and a little arc, and there's my 30 degrees. So the rule is that the angle equals 1/2 of the big arc minus the little arc. So the first thing I'm going to do is I'm going to multiply both sides by 2 to get rid of that fraction. And then, parentheses don't matter there, 110 minus X equals 60. We're going to find out that this angle is 50 degrees. 110 minus 50 is 60, and half of that's 30. So that's how we do that. Here's a good example of the one where we have the two tangent lines that intersect the circle. So we have our little arc, and then we have this big arc. When you have two tangents that intersect your circle, the arcs, you have two arcs, but they add up to 360. So if this arc is X, this arc must be 360 minus X. And the rule says the angle is half of the big arc minus the little arc. And then we solve it from here. Again, I'm going to multiply by 2 to get rid of the 1/2. And then I get 360 minus 2x. And you can subtract your 360 and get negative 260 equals negative 2x. And your x is 130. So we can double check that. This is 130, so that one must be 230. Subtract them, divide by 2, and you get your 50. Okay, so that's a good start on the secants and tangents that intersect outside of the circle. The other place your segments could intersect is inside the circle. So notice these segments intersect inside, but not at the center. Because if they intersect at the center, we have a different rule for that. So in this particular picture, if we're looking at angle 4, think about the fact that you have vertical angles. Those two angles have to be congruent. And the two arcs we're looking at, they're I don't know if I can officially call them vertical arcs, but they're the arcs that correspond to those vertical angles. And we have the same thing over here. If we're talking about angle 5, we look at the vertical angle, we're talking about these two arcs that correspond to those angles. So here's the rule if your chords intersect inside the circle. The angle equals half of arc plus arc. You add the arcs together, divide by 2, and that's going to give you the measure of that angle. And it gives you the measure of both angles because they're vertical. So let's look at some examples of that. So I'm going back to the worksheet here, and I'm going to look at number 4. So notice here's my X, and the arcs that are involved are, here's my vertical angles. So it's the 50 and the 200. According to my rule, since the chords intersect inside the circle, the angle is half of arc plus arc. So half of 250 should give me 125 degrees for these two angles in the center. All right, we can also look at number 5, same type of question. Notice the 150 is here, but we're looking at the arcs over here. So I need to know the measure of these angles in order to solve this. Well, aren't they a linear pair with the 150? So these angles are each 30s. And my rule says that the angle equals half of arc plus arc. And that would give me x equals 10. Sometimes for a little shortcut, I look at my vertical angles and I add them together. 30 plus 30 is 60. So those two arcs also have to add up to 60. 50 plus 10. Alrighty, let's just do some other practice on this particular piece of paper, and then you'll be ready to try some on your own. So let's look at number 3. Number 3 says the measure of angle A is 81. The measure of angle B is 92. The measure of angle C is 104. And we want to find the measure of arc HG. Okay. So arc HG has something to do with angle D. This angle that goes to here and to here. So this is that example of the two tangent lines. I need this arc all the way around here from H to G, and I'm looking for this little arc here. So let's see what we can come up with. Since this is a quadrilateral, I know that the degrees in a quadrilateral add up to 360. So I can figure out the measure of angle D by doing 360 minus 81 minus 92 minus 104. Find out that angle D is 83 degrees. Once I know that, I can assign values to the little arc. I'm going to make it X. Since this other arc is the rest of the circle, I'm going to call it 360 minus X. That's going to come in handy when you have your two tangent lines. So the rule is the vertex is outside of the circle, so the angle equals half of arc minus the other arc. 360 minus X is the big arc, X is the little arc, so you need both of those X's. If I multiply both sides by 2, I can get rid of that 1/2. So 166 equals 360 minus 2x. And we solve it, and what should we get? 194 equals 2x. And from that, I get x equals 97. So the measure of arc HG is 97 degrees. That's kind of a tricky one. Then we get to number 6. We want to find the measure of angle Y here in the middle. And so we're going to work with our arcs on the outsides. Since we know that all of the arcs in a circle add up to 360, we're going to add them up. 2x, 4x, 7x, 12x, plus 12, let's see, 10, 20, 36, equals 360. So that's going to help me find x, and then I can find this angle y that's in the middle. So from this one, 360 minus 36 divided by 12, I get x equals 27. And then I can find y once I plug 27 in for these arcs. 3 times 27 plus 13. This arc is 94. 2 times 27 plus 12. This arc is 66. So remember, these are my two vertical angles. So these are the two arcs that I need to look at to find angle y. Since it's inside the circle, you're always looking at the vertex. The angle equals half of the arc plus arc. So half of 66 plus 94 equals 80. Y equals 80 degrees. All right, let's do one more. This one wants us to find the measure of angle C. And I've got x's and y's, so I think I'm going to have to do a system of equations here. So let's take a look. I have measures for all of the arcs in the circle, so I'm going to add up all of my arcs to equal 360. So that's 10x, 16x, plus 4y equals 360. And then I'm going to take my rule for my angle here and set up an equation for that. So for the angle, we know it's outside the circle. The angle is half of the arc, the big arc, minus the little arc. So 7x plus 3y minus 3x plus y. So let's simplify that out. We get 7x minus 3x is 4x. Don't forget to distribute that negative. 3y minus y is 2y. Now when I multiply both sides by 2, I get 10y equals 4x plus 2y. I can get all the y's together. 8y equals 4x. And if I divide both sides by 4, x equals 2y. I'm going to use that in substitution over here on this other equation. So where it said 16x, I'm going to put 2y in place of that x. And I'll solve from here. So 32 plus 4 is 36y. All of that. And y equals 10. And I think we can find angle C now, because if y is 10, angle C is 50 degrees. So that was a pretty tough one. You had to use all your variables, use your system of two equations, substitute, and then find the missing value. We could plug these back in and find the other numbers and check and make sure it really worked if we wanted to. But there's your lesson for when angles intersect inside or outside of the circle.